Thank you everyone for joining today. First of all, so if you have any questions, please, you can raise a question in the Q&A, but I'll answer it after the presentation. So thank you for joining today in this webinar. I'm Panos. I'm a research fellow in the Department of Chemical Engineering at UCL. And today I'll present you how we can use artificial intelligence in chemical engineering, basically to improve the quality of life, which is part of the research that we are doing in this department. So allow me to introduce myself. I'm from Athens, Greece. I studied chemical engineering in Athens, in National Technical University of Athens. After finishing this degree, I joined the University of Manchester for a PhD, again in chemical engineering. And in 2019, I joined the department here in UCL, and specifically the System Identification Group, which is led by Federico Galvanin, where in this group we build frameworks for experiments and automated frameworks for optimization. In this particular project, it's not only UCL, but it involves the companies like IBM and AstraZeneca and other universities like the University of Leeds. So I personally really like chemical engineering because it combines most of the fundamental sciences and they make them useful for us, for people. So we can see chemical engineering as a combination of physics, computer science, chemistry, and mathematics. And this is because we really need the laws of physics to design our plants, to design new materials. We need the mathematics to derive our laws, the chemistry because everything inside is about chemistry and chemical reactions, and computer science to be able to program all our methods. So we use all of these fundamental sciences in order to produce pharmaceutical products, design new materials, and operate chemical plants. But here in this presentation, I'll try to show you some examples on how actually the artificial intelligence helps chemical engineering to achieve those goals in a more intelligent way. So artificial intelligence, or AI, in chemical engineering can be found in different aspects, and it's mainly used for the automated design of materials, drug discovery, self-optimization for plants. So we just basically give a plant to our AI agent, and then we'll try to optimize it itself. And the safe operation of plants, because it's not always trivial to find how to operate the plant safely. So in classic chemical engineering, what we usually do, we have some data and we have the methods and tools that are derived by the laws of physics, and then we get the output. Whereas in the intelligent chemical engineering, we get the outputs and the data, and then the AI will give us the methods and tools to achieve our goals. So here in UCL, we have developed a tool where we're using cloud computing and AI in order to automate experiments and analyze our chemical systems without having any human interaction. So here's an example where in UCL, we have the algorithms. The experimental setup or lab here is in a different place, and specifically now is in University of Leeds. And what is basically happening is that the human only is there to provide some initial setup, and then the lab will start to operate and provide data to a cloud. Then our algorithm go to the cloud and takes the data, analyze them, designs an experiment, send it to the cloud, and then the experimental setup itself picks this design and then start operating the new experiment. So basically this loop continues, it's a closed loop. there is no human there to twist anything in the experimental setup or the algorithm. Everything is automated. And in the end, basically, we get our goal. We have analyzed the system, and we have accelerated the way of designing the experiments and getting our results. So another research that we conduct here is we use artificial intelligence in order to be able to provide the safe operation and the optimal operation for our plants. What I mean by that, usually in chemical engineering, we have to deal with hazardous chemicals, which means that it's not trivial to find where we can be safe. And also it's very hard to find the economic and environmental optimum operation, because we not only want to have a very good economic performance, but also have an environmental one. So AI is there to basically tell us where we can be reliable and operate economically and environmentally. But also will be there to tell us where we can be safe. So basically, we have these two figures at the bottom and we combine them. We will be able to know where we will be managed to operate properly and safely. But this is not only for having this about operation, of having a smart operation, but also to discover new things. And let's see this example where we have the so-called artificial neural networks that are used a lot in AI. We basically are inspired by our own neural system. And we have here, for example, this network where each one of these nodes is supposed to represent a neural, which is a mathematical function. So these complex networks are able to take images and recognize what the image is. For example, here we have Mickey Mouse, Donald Duck, and Goofy. We're providing this image to the network. We are able to recognize if it's basically Mickey Mouse, if it's a Goofy, or if it's Donald. And this is a very simple example and not very chemical engineering one. So a different example that we have a real image now. Here we can see like a street with a lot of people, and we can provide this image to the neural network, and the neural network will be able to tell us which one of these pixels contains human and which one of these pixels contains an umbrella. As we see here, the red boxes have the humans and the green boxes have the umbrella. Again, not a very chemical engineering example, but we can see the capabilities of such a neural network. So if we see how we can actually use this technology, because it seems that it's not very into our discipline. What we can do now is to take this image, what contains cells. So basically what we want to do is to count these cells because we want to find, we want to use this information for different tasks like grading cancer. And in order to avoid a human to go and count each one of these cells, we use this artificial neural network that is able to take the image on the left-hand side and produce the image on the right-hand side, where it can recognize each one of individual cells and count them. This way, we don't have the human error, and we're able to automate this behavior and save a lot of time from our doctors. Another example, again from chemical engineering, is here where we have two chemicals, and also we have some measured concentrations. So we took these two chemicals, we put them to react, and then we got some concentration. So basically, in the same exactly concept, the neural network is able now not to recognize or segment any image, but to recognize the chemical reaction that we have in this system. So you only need to get some concentrations and get the information from the chemicals, and they will give us the mechanism that we have in this reaction. So this is a very fundamental aspect of chemical engineering, and it's very important to be able to recognize the mechanism, because it's not always trivial to get this information from experiments or from a chemist. So another aspect here that we use in artificial intelligence is reinforcement learning. Reinforcement learning is initially inspired by the training of dogs. Basically, now we don't know exactly how the dog we want to behave, but we want them to learn a task. We know if the task is good or not, if the dog will perform well or not, but we don't know exactly how the dog will perform. So we're basically trying to train this dog, and then if the dog performs well, we give them a treat, and then we continue this loop until the dog learns all the tasks that we want. So the same exactly mechanism is used in artificial intelligence, where we don't know exactly how what operation we want to have, but we're able to tell if the operation is good or not. So what's happening is, again, we're using these artificial neural networks, these complex networks that are inspired by our neural system, and it's trying to self-play with our systems. And we allow the neural network to tell how to operate our systems and find all of these behaviors that will be optimum according to our criteria. So simply as that, we are able to have an optimum operation for our real complex systems that is very difficult to handle with classic chemical engineering techniques. So all in all, like putting together how we use artificial intelligence and in chemical engineering with reinforcement learning and recognize all the chemical systems we have, we can put everything in this slide, where we have here on the left hand side, we have the lab, which is actually the real lab that we are working, doing our chemical reactions. And here everything is, we know very well how the environment behaves. We can control everything, temperature, pressure, everything is very well controlled. So given this, we can basically use this AI system and try to find how to behave in this lab. So we can give as much time as we want because it's in our lab, and we can control everything. But then we can take this and go to the real world, go to the real system, and then this AI system will be able to adapt to the real world and try to find what is the optimum operation and the safe operation for this real world problem. And this is very important because we can go and scale up our operation from something small and very well behaved to something very uncertain that we don't know how really to operate. That would be my presentation. It was short. I hope I gave you enough information how we use artificial intelligence here briefly in this department in chemical engineering. I'd like to thank the PSRC for funding my research, and also Federico, Marco, and Arun. Marco and Arun are my collaborators, and Federico is the leader of our group. Thank you very much for your attention. So I don't know if you had any questions or we want me to go again through any of the slides. Please feel free to ask anything. You can ask me anything about my background. You can ask me about the research. Feel free about that. All right. So the first question is, please explain how AI is used to predict the reaction mechanism. All right. So how this happening is that we basically have the concentrations and we have any potential mechanism. So it's a bunch of mechanisms that we can generate. And in the same way that artificial neural network recognize if a picture is a human or an umbrella or a dog, is able to recognize which mechanism is in this system. The second question is, will be expected to learn AI during the chemical engineering course? I cannot be sure about this question about the program. We have a lot of system engineering in this program, but you should send an email to the department in order to. It will definitely tell you if you learn AI algorithms there. You will learn all the fundamentals that you will use in AI for sure. So the next question is, how applicable is the research in the industry? So it has already been used in industry AI, and it is used, first of all, for the image recognition. We can use for fault detection. So basically, we're able to find some faults in our instruments. Other ways that we use artificial intelligence in industry is in control. So we are able to basically find the way that our systems dynamically behave without using any particular model, and then use this to control our systems. So of course, sometimes in the classic industries like the petroleum one, like in the refineries, they would prefer to use the more classic methods. But we see that as the years go by, we have more and more application of these AI algorithms in industry. And we can see more and more in bio processes, where it is more difficult to basically use the classic techniques to optimize and control our systems. So the next question is, hello, could you please explain in detail how the neural network works? Is it a binary system? All right, so I'll try to be as detailed as I can. So no, it's not a binary system. So you need to imagine it as a function where basically we have each one. If you can see, I guess you can see my my slide 9 here. Let me go actually to this one, slide 8. So this is a complex mathematical system. So every one of these nodes has a function, and this function behaves basically as a neuron. So it is like a sigmoid, so taking a signal and then it transforms it to something that goes from 0 to 1 smoothly. So each one of these nodes has also have some parameters. So what is basically happening is that we measure something. Let's say we get the image, and then will give us as a result in this image recognition a binary that will tell us, not a binary, sorry, a probability will tell us whether or not what we see is what we're expecting. For example, if we want to predict if we have humans, it will give us a probability of each one of the pixels that we have, if it is a human or not. So it will tell us that with 95%, this is a human. With 90% is a human. So the main concept of neural network is that because it's so complex and it has this very special structure, there are some mathematical theorems that telling us that we can approximate any mathematical function using an arbitrary neural network. So we can find a neural network that will be able to approximate any function. And any function can be a system that looks like this, taking an image, process it, and then tell us if it's a human or not. I hope I answered this question. So how to scale up through AI? Oh, this is a very nice question. So the way that we scale up through AI is as follows. You basically train your neural network, you train your AI model into your well-behaved system. And then you take this and you put it in the real world, right? there, you're able to measure some of the concentrations of the real world and retrain these chains, and finding this AI is called training. So you can retrain your neural network in the real system using the already knowledge that has acquired. This is called transfer learning, and is able the AI to adapt from the very well behaved system to the uncertain world, because already has the intuition basically of what is happening in the system, and is able to go to the real world and just with some modifications on this model be able to scale up and find the optimal operations there. This is a very nice example from reinforcement learning, where because it is able, we have trained the neural network to perform this task, then it can go to the real system and try to perform the same task. It's like, imagine having, again, like in the same example with a dog, imagine that we put a dog to perform a task in a room that everything is very well behaved, and then we take the dog and we go somewhere else where there are more people and there are more obstacles. And we ask the dog, okay, now go and do the same task. And basically it may fail a little bit, but it will perform much better than starting there. And we'll be able to see how to adapt and how things will go. Hope I answered that. So how information is processed in artificial intelligence? Are they programmed? Yes. So the information, so artificial intelligence, it can contain a lot of things, and particularly here that we're using artificial neural networks, they're programmed. So as I mentioned, chemical engineering can use a lot of different fundamental sciences, including computer science. So we don't do computer science, but we're using programming languages in order to perform our tasks. So we basically, because artificial neural networks and the most things in artificial intelligence are mathematical functions, we basically are able to program these mathematical functions and train them using the data that we have. So yes, we need to use programming language to perform this artificial intelligence. Another question: how do you ensure the reliability of the results from the simulations run by AI? Oh, that's a very nice question. All right. So this is a very hot topic, actually, on how we have this reliability. And that's why we want to use some safety in these methods. So basically, it's not very reliable to just take the AI and throw it in a real system, right? Because we don't know how this will work. So in order to be sure that we are reliable, we first deploy everything in something that we know. And by reliable, we were able to tell two things. The one is that we have the right accuracy. Basically, we can measure the performance of this AI using accuracy from the simulation. Okay, there everything will be good. But then when we go to the real system, then we are able to have some theorems, and we are able to use some more sophisticated algorithms to make sure that the safety and the reliability is also assured in the real system. And so there again is a little bit of how we can basically transfer this learning and how we can go from the simulations run by the AI and go to the real system. And it's very interesting on how we do that. So I could go in more details, but more or less we can see that this transfer learning, together with some more theorems that we're able to build, can ensure this reliability in the real system. So is most of the chemical engineering related AI dealing with narrow goal-oriented AI, or will chemical engineering be researching towards deep AI as well? Oh, well, we do deep AI, right? So I don't know if you what you mean by narrow goal-oriented AI and deep AI, but basically most of the methods that are used in artificial intelligence can be used in chemical engineering. So there are some like creating even those actually that you can create your own images. So there are some artificial intelligence methods that you can basically create an image that is completely artificial and looks like something. For example, you can create a new image of a human, and this human doesn't exist, but the AI is able to basically duplicate how humans look like and create this picture. The same with animals, portraits, everything. So this concept will look like, okay, there's no way this can be used in chemical engineering. It can be used for creating some artificial data sets and be used for other mechanisms, other methods that need a lot of data. So we can use those artificially generated data from the AI because it can basically tell how the data look like and try to create new data that will help other methods do their job. So basically, we use, for these reasons and for whatever I showed here, we use deep neural networks because it's very complex and deep in the structure. And we basically use everything that, if you can give me more details on what you mean by deep AI, we use like everything AI can be used potentially in chemical engineering. The next question is, I could see that AI mostly revolves around chemical reaction engineering. How is used in other disciplines of chemical engineering? Oh, so I was focusing this part of the AI because on my main research in that. But there are several examples on different in different aspects of chemical engineering. And one of these is recently published in Nature paper, where you can discover new drugs and you can discover new materials using AI techniques. So again, in the same way that you're using the neural networks, you're able to, or we find the mechanism, you're able to recognize which combination of components in this pharmaceutical products will be giving you the result that you want. So it is widely used for also designing solvents. It is used for, again, finding new drugs, discovering new materials. So basically, in many aspects of chemical engineering, we can find AI. So the next question, is there any open source software where I can feed data and use ANN? Yes, of course. So the software, there are several open source softwares, including TensorFlow, Keras, which is the one that is programmed by Google, and also PyTorch. So both of them are open source, and the most actually softwares that are used in AI are open source, and that's why they have been so widely used, because everyone can take it. They're very well documented, and you can actually use them. So basically, the only thing that you will need to know is Python. Python is a programming language that is used mainly in AI. So the first step, if I wanted to go and do AI, I would first go and do like a tutorial for Python, learn the basics, learn how to use this programming language, and then go to those websites. Like if you Google TensorFlow, or if you Google PyTorch, or Google websites, and all of these have like loads of tutorials and loads of open source material that you can use and train those ANN. And trust me, if you get familiar with the programming language and you get familiar with some concepts of the artificial intelligence, it's super easy to perform those tasks. So would you give some recommended resources, articles, journals, etc., for someone who's interested in learning more about this topic? Thank you. All right. Yeah, actually, I could provide some resources, some articles with some of the work that is happening in this topic, like some fundamentals and some more advanced. And I'm not sure how I can do this here, but I could post it in Twitter. If you follow me in Twitter, I could post it under the advertising of this webinar. I can post all the relevant information. Okay, what are the current applications of artificial intelligence in chemical engineering? All right, so yeah, so again, the main applications. So the first application ever that we were doing artificial intelligence in chemical engineering was the control. Control is a very fundamental aspect of chemical engineering, because when you operate something, you operate it in some steady state. So steady state means that everything does not change with time. But to go to this status that nothing changes in time, because you know, when you produce something, you want to produce it steadily, and you want to always have the same conditions. So when you change, when things changing, for example, you have a different inflow, and you need to change, for example, some specification of your product, you have some transient behavior. So this is one of the applications of artificial intelligence, to be able to control this behavior, to go from the one stage to the other stage very fast and safely. So this was basically one of the first applications of artificial intelligence in chemical engineering. So the other applications is again the design of materials. Another very interesting is the design of solvents, finding the mechanisms of chemical reactions, discover new drugs, find where we can operate safely in real time, and all of this. If we're dealing with artificial neural networks, which I assume applies machine learning, how do we deal with cases where an iteration does not have the training data, cannot provide an accurate or maybe even no prediction improvements at all? All right. So basically there are methods for when we cannot basically have the training data. So the one is to basically create artificial data. And the other one, like, we need to go more to specific details, but basically you can interpolate from data to data and be able to create artificial data points in order to artificial neural network to go through those and try to predict how the system will behave. So if it cannot provide accurate or prediction at all, then you need to start and rethinking about your system. So you need to go and you change the structure of the neural network. Is all about how you design your inputs of the neural network and how you design the outputs. So it shouldn't be a complete black box that you throw it into your system, you're expecting things to work. So you need to design it properly. So you need to know what the neural network should get, should measure, should observe, and what you want your neural network to do. So if you have a data set that does not have some data points, or you cannot have for all the variables data points, then there are techniques that can deal with this and basically either artificially generate new data, or you like work on this scarce data set itself. Are there implications, disadvantages of using AI? Yes, of course. I would say that the main disadvantage of using AI is that people cannot really explain the output of the AI. And this is a big disadvantage for basically when you want to operate something and you're using the fundamental laws of chemical engineering, you can basically interpret everything. You can see how your system behaves, you can predict, you can see what's going wrong and what is not. But having AI, which is a black box for, in the sense of chemical engineering, it's a mathematical, again, it's a complex mathematical function. Basically, you need to see it as input-output, and or people basically see it as an input-output. So this is a very big disadvantage. And there's a lot of work on how you can actually be able to interpret this AI, and or how you can combine the fundamental laws with those AI in order to make everything more interpretable. And we are working actually on that, where we're trying to use the basic kinetic laws that we have, but cannot be generalized for chemical engineering systems that are complex. And we're using the AI in order to basically help those kinetic models to work on more complex systems. So on the one hand, we have this, we can tell what's going wrong with our system because we have a part of it that we know very well. And on the other hand, we can help it with this part of AI. This is called basically hybrid model because it can use both fundamental laws and the base and AI. So I'm interested in how AI can help in digital rock. I want to predict properties from SEM images. The challenge is that not enough data. How can I generate images from few SEM images to make predictions? All right. So I'm not really an expert on how you could do the how you can help in digital rock, but I will give you my intuition on how you can deal with data that are not enough. So the first thing I would do is that I will scale down my machine learning technique, my AI. So I wouldn't use an artificial neural network, but I will use the so-called Gaussian processes. So Gaussian processes can deal with much less data, and it can predict not as accurate as a neural network, but it can predict accurately enough for our purposes. And not only that, it can, even though it cannot predict as accurately, it can give us a confidence interval for the prediction. So the one way would be that. The other way is that to use those GAN, the generative adversarial networks that can generate new images. I'm not sure how it would work in the same images that you're mentioning, but it's a thing is worth giving a try if you have those issues. The next question is, can artificial intelligence be used to optimize process and finding operating conditions? Yes. Yes, actually, that's exactly what we're doing. We're using artificial intelligence to optimize processes and finding those operating conditions. And not only, so we can use it for batch processes, for continuous reactions. We can use it for basically the most of the processes we can. And this is one of the biggest advantages, is that sometimes we don't even need a very detailed model for our process. We can basically either use then AI to build a model for the process and then use the AI to optimize this process. So we have worked on that in a lot of many different ways on how we can optimize this process intelligently. One of these called real-time optimization, where you start and you want to find your real optimum operation of your system, but you don't know how your real system behaves. So basically you're using this AI and you start from a point and then you perform some tasks, and this AI step by step is trying to find the optimum operation of your system, and it's working very well. I can post like information from that as well, like some papers, some additional information how this actually works. How can I generate images from few SEM images to make prediction using AI? All right. So I think I answered this question again. So you can use, so in order to generate new images using SEM images, I would go to GAN and see if it can work. It is a very hot topic and there is a lot of information that which I can again provide some papers to that, but I cannot give you more information for this for that question. How long would it take to program the AI to perform a specific task? Say, for example, programming a simulation for a chemical process. All right. So this depends clearly on the person who do it. So the objective answer is easy. So if you see the code to do that is like a couple of lines of code. So you basically need not couple, like you need like 4 or 5 lines to write how the neural network look like. You need some lines to import your data, and then you need 3 to 4 lines basically to be able to train your AI. And then it's really easy. I would say everything can be .fit, .predict. So you basically taking your data, you press your model .fit, and then you fit it, and then you press .predict, and then you predict it. So just we need to be careful because you may have issues on being very naive on how you implement stuff. So people usually do that, like .fit, .predict. And they will like, if you try out, that's how you should do it. But then if you start looking more on the details on how things are working, backgrounds on how things can be used, and why you're doing those particular things, because there are a lot of twists in those techniques. All right. So how do you deal with overfitting, underfitting to ensure AI model can be generalized? Ooh, nice. So basically the overfitting and underfitting is you deal it with the steps of the train. So basically when you start with the artificial neural network, for example, and you have an amount of data, if you have a lot of data, then you can always increase the structure, the complexity of the artificial neural network and see how this will behave. So basically, let's say that you have a data set. Then you split this data set into 3 parts. The one part is a training. We call it training because this will take it and train the neural network. The second part is called validation. And the third part is called test. So what is actually happening is that you have the initial set, which is a training, and you train your neural network. Then you're taking this artificial neural network and you test how it will predict the ones in the validation part, right? So you go to the validation part and you see how you behave. If you see that you basically you perform much worse than the training, so if your training is actually very good, but in the validation you are very bad, it means that you basically overfit it. So you need to reduce the complexity of the network. If you see that that both of the training and the validation are not very well, they don't perform very well, then you basically need to go and increase the complexity. So after all of these iterations between validation and training, then you go to the test set, which is an independent set of the other two, and you test your artificial neural network in this independent test set, and you see how actually your system performs. So this is how basically you need to you can track if you overfit or underfit everything, because you have metrics like accuracy, and you can tell using those 3 data sets if you overfit, underfit, or you have a well if you fit it correctly. So if there is no way that you can if there is no way you can avoid the underfit, then it can be 2 things. The one, you have very small amount of data, and the other one is that you don't provide the right observations to the neural network. So in the system, you may see a lot of things, like you can measure concentration, you can measure temperatures, pressure. So it may happen that from the 3, the only one that affects the system is the pressure. But you only provide concentration and temperature, which means that the neural network won't be able to make any correlation between your input and the output, because basically they don't affect each other. So you need to make sure that you provide the right inputs to the neural network. All right. So are the results of the AI based on pattern recognition or input knowledge facts fed to the machine? I'm not sure I understand the question. But I mean, I don't know what you mean by machine, but yes, you can basically program this AI and put it either having a chip in any machine. Like, for example, in our case, actually, it's much simpler because of the cloud. For example, in the cloud computing, it's much simpler because we don't need a chip for programming this particular one into the our system. So basically, we have a cloud and we have the computer that provides all the answers, and the cloud takes them, and then it gives them to the machine. So the machine will only read what we'll need to do. So it has its own chips and it has its own ways of dealing with information, but it could do the same if a person goes there and press a button and says, okay, I want this pump to go to 0.3 position, all right? But instead of the human go and saying it is the 0.3, the cloud will give its answer and say, okay, go to 0.3. Do you use graph neural network for prediction of reaction paths? Or how do you input the chemical structures in your ANN? Oh, that's nice. So no, we don't use graph neural networks. This is one of the things that we have in the plan to use. But the chemical structures are not explicitly entered, but they are more like the properties of each one of the chemical. So each one of these chemicals has some particular properties, and these are entered into our neural network together with the data. I would say that the data are most important for input in this neural network. Yeah, but this is, graph neural network can also be used. How likely is that AI will become, how likely is that AI will become too smart to a point where it can be dangerous or turn against us? All right. I think it's not very easy to happen. There are some talks around that on how smart this can be. It can be very smart, but we can always control it, and it's very hard to take over. So I don't think we will have any sort of Terminator scenario for some years, but because we are the ones that train it and we are the ones that control it, I don't think we have any issues of being dangerous. The last question that I see here is that I don't have any coding experience. Would this be something I need to know? Yes. So you will definitely need to learn coding. It is very important for artificial intelligence because you need to code everything, but it's not the bottleneck. So basically, it's very intuitive sometimes to learn. It's very fun. So I would go in some tutorials that I can also post in Twitter, and you can see how you can code very basic things. See some fundamentals from coding, and then having this knowledge, you can go through and build your AI platforms. So you shouldn't be discouraged by that. Many people, when they start, for example, their degrees, they don't know coding, but you learn code. So you don't born knowing how to code, but you need to learn. And from my experience, it's a really fun experience. So it's really fun to see and make something that is very complex to do it by hand and write it in the paper and see it in the do it very fast in the program, right? So at least for me, chemical engineering was one of the most fun experiences to learn how to code. encode those principles of chemical engineering in programming languages. So I don't think I have any more questions. Do you have any recommendations on where to learn coding? Do you have any recommendation which coding language to learn? Yes, again, I'll post some tutorials of Python on Twitter today, hopefully. And you can learn some basic stuff for coding. And the language that I recommend the most, and actually the only one that I recommend at this point, is Python, because it's the one that all the AI is happening there. It's very easy to learn. Doesn't have all the weird stuff that you need to do, some allocation of memories. It's very easy to learn. My experience is that is the easiest language to learn at this point. Like, for example, Fortran has much more complexity. C, it's much harder. Python is there, it's easy, and the most of the things will be open source. All right, so that's the only questions I see now. So I think I answered both the questions of code for coding. I don't know if there are more things. Sorry for the if I don't answer properly this question about the same images. I don't have the experience with the same images, but hopefully I gave some help. All right, I can't wait here for more minutes. Like, we have around 10 more minutes. So if you have any other questions, please go ahead and ask me. By the way, so for the question of the graph neural networks, just now that I remember, like I have a nice paper. I recently saw this presentation where basically you use a graph neural network and you're taking the structures of the of each one of the chemicals, and you combine it with molecular simulations. So that was a very interesting paper where you're trying to accelerate the molecular simulations, and you're using those artificial neural networks, and you're getting the structures, and you're trying to make all of these combinations for the structure. Could you explain how AI could diagnose faults and control systems in a plant? Oh, that's nice. Yes, of course. You can basically, the AI is able to, you're training to know how things are operating properly. And basically, when something will go wrong, it will find that this is not according to how the operation should be. And then it will raise basically a disturbance signal. And then the control system will go and make try to change it. But specifically for control, you can do something. You can use the artificial neural network itself and train to control your system. So basically, you go and will sample the concentrations in time, and then it will tell you how, for example, the pumps should operate in time in order to achieve your goals. This is a little bit more on the reinforcement learning side, where you don't know exactly how your controller should perform, how it should work, but you can tell if it performs well or not. You can tell if your control action goes in the right direction. So reinforcement learning cannot tell you how exactly the control should be, and you don't really care how the control should be. You should not be that fixed on how those control actions should be. But it will tell if this trajectory is good or not. So is a matrix of neurons used differently clear for its process? Thank you. I'm not sure what you mean by that, but how in general happening is that it's one of these, you have a neural network for each one of the process, right? So you train it for individual process. So you don't have one for all the processes. So you basically have, you train those weights of the neurons for each one of the process. So you can keep the structure of the neurons fixed. So those mathematical functions in the sigmoid, or it's a hyperbolic tangent, or there's some piecewise linear functions. But in general can be fixed, and then you change your weights. But this is also part of this validation state, where you are allowed to go and change those functions, and basically see how this how your neural network will perform. All right. Do you think AI can change the way things are done in chemical engineering? Well, should not change it, the fundamental, right? But it is already changing the way that we are doing things in chemical engineering. So, but back in the day, probably would be ridiculous to substitute the model that we're using for our reactors with neural networks. Right now is a very hot topic. You sometimes you're unable to predict some phenomena that are really complex, and this can be seen very often in these bioreactors, because you're not really able to get this mechanism, right? So it is very hard without a mechanism and without a detailed kinetic reaction to predict how your reactor will work. So what you do, you employ those artificial neural networks, and you basically train it on your data that you have to predict your concentrations in the bioreactor. Combined with, for example, if you know that you have a mechanism that it's okay, it can describe your physical system kind of okay, you can combine it with your neural network together to make those predictions. Sometimes you substitute some terms in your kinetic laws with an artificial intelligence itself, and you use this new kinetic in order to make the predictions. Because, for example, some terms in the kinetics are a function of temperature, but you're kind of sure for the rest of the kinetic. So this term that is a function of temperature, and there is no way you can find this function. You substitute it with this artificial neural network, and then you train it to make the predictions properly, and you will see much better results. Are there any current industrial applications for AI in chemical engineering? Yes. So I think these there are several examples that we actually use those hybrid models in industrial applications. So I can try to find some of the papers and send you these, but I think both like some of the controls and the optimizations or the real-time optimization has already started to use. So recently I saw one of the papers for trying to find the optimal operation of wind turbines. So you're able to basically find the optimal operation using those AI techniques for those applications. Don't know if you have any last question. Okay, can AI be used to control batch systems and how? Yes, it can definitely can. I have personally actually worked on that, and you do it using one of the I think very important ways of doing it is using reinforcement learning. So you basically you use a neural network, an artificial neural network, to try to optimize your product at the end of the batch. And then you go in a batch-to-batch learning. So basically, you complete one batch, you update your neural network, and then you complete the next batch, and the next batch, and the next batch, until your neural network is completed. So how I personally did that is that having a very contained, like a model that I know that it probably will describe the physical system. Train the neural network using that model, simulating in silico all the behavior that I believe it will have, and then take it to the system that will probably be the real one, and adapt it with only a few training points for the control. So just to give you an idea of numbers, to do it for your simple system with simulations, you need around 100 of batches, but it's in silico, right? It's a real system, so you don't spend anything. And you go to the real system, you need around 10 to 20. So it is a significant reduction of training that you need to do. And of course, the difference that you get from not using it and using just your simple model is very it's really nice to see how different the performance is. And one of the real nice things is that you, in the classic control, sometimes you will have to assume something about your system, for example, to be your derivative continuous. Where we show that basically, even in this case, that the rate changing sharply, you don't really need to have this assumption, and you can basically optimize the dynamic behavior of your system. The next question: how exactly does the ANN determine reaction mechanism? Do you have to program known reactions beforehand? Thank you. So yeah, usually you have to basically have a bunch of reactions that you think that will happen, and then the ANN will be able to determine. So there are some works from some researchers in MIT that are trying to tackle this problem as well. We are working on that as well. It's a very difficult problem, but right now what you basically do, you're trying to determine how is your mechanism given some arbitrary steps that you believe that you may have. This can be like a load of them, right? That it would be impossible to iterate through all of them in conditions that we know and find which one is the right one. All right. So I think, are we going to stop it now? I think we reached our time. I don't see any other question. So at this point, I'll thank you all for joining us today. I'll try to post materials underneath this Twitter post that advertising this webinar, and hopefully I'll see you again. Now I'll stop sharing my screen.